Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Monday Musings. We're going to talk about extraterrestrial volcanoes today. Volcanoes are not exclusive to Earth. In fact, we don't even have the most volcanoes in the solar system. That record is held by our sister planet Venus. The surface of Venus is about 90% basalt. And this is a photograph from about 40 years ago of the surface of Venus. So it's pretty barren looking. The second highest mountain on Venus and its tallest volcano is Mayat Mons, a 5-mile high shield volcano. Most of Venus's volcanoes are shield volcanoes, although there are some pancake domes which are exclusively found on Venus. Due to all the volcanism, the atmosphere is very dense, primarily made out of carbon dioxide. And it also rains sulfuric acid, which is just great for not planning a vacation there. Once, much like us, Mars no longer contains active volcanism, but it does possess the largest volcano in our solar system, Olympus Mons. This shield volcano is over 13.6 miles high, or 21.9 kilometers, about 2.5 times taller than Mount Everest, and covering an area the size of Poland. It last erupted 25 million years ago during the Oligocene. Boop. Right here. So, it's been a while since Mars had any active tectonism, volcanism, anything. But also in the grand scheme of things, it also hasn't been that long either, so do with that what you will. The most volcanically active body isn't even a planet, it's a moon. Io has at least 150 active volcanoes, with 400 as the estimated total from observations made. And here's just a photograph taken with heat imaging, so you can see all of the volcanoes that are actively erupting on Io. It's insane. For comparison, here on Earth, there's around 50 to 70 that are actively erupting at any one time, so that's a hell of a lot more than we have. Now, once upon a time, they thought that most of the internal heat on Io came from like this big magma ocean underneath the surface. Turns out, Io's main source of internal heat comes from tidal forces generated by Jupiter's gravitational pull. So, big planet makes heat. And the molten flows are also not typical magmas, at least not all of them are. Analysis by Voyager led scientists to believe that the lava flows were molten sulfur. And in case you're wondering, that's what molten sulfur looks like. It looks kind of like cheese. The coloration of the flows were consistent with its various allotropes. So allotropes are just different, like, internal structures of how the crystals are built up. How the atoms are built up, I should say. So there's a couple different allotropes. And they're a function of the temperature of polyatomic sulfur and the packing and bonding of the atoms. So they were seeing that. Now, it was later confirmed that silicate magmas do exist on Io as well. In fact, with more sophisticated equipment, they were able to determine that it does primarily have silicate magmas just like us, with sulfur magmas as a secondary role. Well, that's still pretty cool, though. I mean, you don't really hear about sulfur magmas all that much. And speaking of moons, our own moon also has extinct volcanoes on it. Shield volcanoes, pyroclastic deposits, and lava plains have been found on the surface. Most volcanic activity seems to have petered out about 1 billion years ago, but there may have been scattered eruptions until about 50 million years ago. So even our moon was kind of active until fairly recently. So, you know, cool stuff to learn about space volcanoes. Well, I hope you had fun. Thanks for coming to the lesson, and make sure you tune in tomorrow for some fun trivia. Fossil you later.